Hello. Today we need to discuss the idea of scientific notation. Chances are you have been familiarized with scientific notation either in your math class or in another science class, and what you learned about it then is going to be the same as what you learn about it today. So hopefully this is just a refresher course for the vast majority of you. Now, a couple of things. Scientific notation is a way for scientists and mathematicians to write numbers that are incredibly large or incredibly small in a brief manner that everybody will understand. And the rules are always the same, no matter where you are or what science you're in or what math class you're in. The rules are always the same. So, for example, you might see below that we have the number 602, and that 602 has 21 zeros after it. And those 21 zeros are really important. Like, that's 602 with a lot of zeros after it. That is an incredibly large number, and that number is going to be a number that's going to be really important in chemistry in the next month or so. So the other thing I want to point out, as long as I'm kind of talking about numbers and zeros, generally speaking, when I talk about numbers that are bigger than 10,000, so numbers that are bigger than the 10,000ths place, generally speaking, I will start to separate the digits instead of with a space instead of using a comma. So like 602 with all those zeros after it, there's nothing wrong with that number. What it is just that I'm separating them with a space instead of a comma. And so if you wanted to go back and draw in a comma, that's fine. I have no problem with that. But just note that on worksheets and tests, a lot of times if you see spaces, that's the way I do it. And also, when numbers are smaller than 0 or smaller than 1, I will represent them with spaces as well. And at the end, I just might put a bunch together. You can draw commas in. I don't really have an opinion on it one way or another. It's just something that I do. So in any case, the 602 or 602 with all those zeros after it versus the 1, 2, 3, 6, 9, 10, 11, the 11 leading zeros. Those 11 leading zeros up to the 72, those are holding place. And all of those zeros are really important when it comes to talking about the number. So like, we can't just like cut it off and write 602, because if we cut it off and write 602, 602 is very different than 602 with 21 zeros after it. And so that's what scientific notation is really getting after. The other thing that is important is if you just wrote 0.72, well, 0.72 is significantly larger than 0.0000000000072. So those are very important placeholders, and so that's what scientific notation does, is it allows us to communicate how many zeros or how many placeholders there are. So in the case of 602 with 21 zeros after it, it becomes 6.02 times 10 to the 23rd, okay? And then in the case of the 0.0000000000072, it becomes 7.2 times 10 to the minus 12. And so those two numbers, the way that they're written, mean the exact same thing as the numbers above. Now, the basic format is there's always a base number, and it's going to be times 10 to some exponent. So the base number always has to be a number between 1 and 10, okay? But it can't ever be 10. So sometimes you'll see textbooks or some teachers will say it's a number between 1 and 10. A lot of times what I like to say is it's a number between 1 and like 9.9999999. The exponent can be positive or it can be negative. The positive exponent tells me that my number is bigger than 1. Okay. And the negative exponent tells me that my number in scientific notation is less or smaller than 1. Okay. And that's really all that this is telling us. And then the exponent also tells us the number of places to move the decimal, which we'll talk about that in a second. So moving on to the next slide. When we talk about putting numbers into scientific notation, there's just a couple of things that we have to keep track of. One of the things that we have to keep track of is where we put a decimal point. So as I said earlier in the base or the basic format, that first number, something times 10 to the, has to be between 1 and 9.9. So generally speaking, when you're looking at a large number or a small number, I generally look for I generally find a place to put the decimal in between numbers that will give me something that's less than 10. Then we figure out how many places you need to move the decimal to get your number to match the original number, and that becomes your exponent. And then the other thing is that if you move the decimal to the left, the exponent is negative. If you move the decimal to the right, the exponent is positive. And once again, I'd like to reiterate that a negative exponent it equals a number that is less than 1. And a positive exponent equals a number that is larger than 1. And there might be some semantic things that a math person might say about that, but that's kind of the way that I've always thought about it, and it's always treated me well. All right, so now the last thing we're going to do is we're going to go through a couple of examples of going from a number or writing a number to scientific, writing a regular number in long form to a number in scientific notation, and then the reverse. So here's what we're going to do is we're going to go through that through this first example. So in 1A, I see that I have the number 0.00034, or I'm sorry, 0.0003240. The fact that there is a decimal at the beginning tells me that this number is less than 1. So what I'm going to do is I'm going to look for the place where I can place a decimal that will give me a number that is between 1 and 9.9. So if I start moving this decimal here, it's still not, I still have a number that's between 1 and 9.9. And if I move it here, it's not a number between 1 and 9.9. And if I move it here, it's not a number between 1 and 9.9. But if I move it here, I have 3.240, which is a number between 1 and 9.99. So I'm going to write that as my base number, 3.240. And I'm going to include the 0 here just because it's at the end of the number, so I think it might be important. Then what I'm going to do is I'm going to add the times 10, and now I'm going to figure out what type of an exponent I need to have. So again, I either A, move the decimal to the right, which tells me I should have a negative exponent, or the way I look at it also would be the number is less than 1, so I need to have a negative exponent. Now, one of the common mistakes that students make when they're doing scientific notation is that they count zeros instead of number of places that the decimal was moved. So if you count zeros, you might say, oh, this would be 3.240 times 10 to the minus 3, and you'd be off by a factor of 10. So what I usually tell students is to count how many places you move the decimal. So 1, 2, 3, 4. So this has to be 3.240 times 10 to the minus 4. In the case of 6 million, which is what that is, we again have to find a spot to put the decimal that makes the number that makes the base number be between 1 and 9.9. So I can see pretty quickly that it's going to be like 6. Okay. But like to illustrate the point, I'm going to say, pretend that there's a decimal there because there should be. And I'm going to say, well, if I move it here, it goes from 6 million to 600,000. If I move the decimal here, it goes from 600,000 to 60,000. And if I move the decimal here, it goes from, or rather it goes to here, then it goes from 60,000 to 6,000. If If I move it one more spot over, it goes to 600. If I move to one spot over, it goes to 60. And if I move to one spot over, it goes to 6. So this time I'm not going to put anything behind it, but I am going to put my decimal there. And I'm going to say 6 times 10. And again, I move the decimal to the left, so that tells me that it's going to be a positive exponent. Or the other way that we can think about it is if the original number is bigger than 1, which 6 million is, it also has to be a positive exponent. So then the next thing that I'm going to do here is I'm going to go back and I'm going to count not the number of zeros, but the number of places that I moved the decimal. So I moved it 1, 2, 3, 4, 5, 6 spots. So this is 6 times 10 to the 6. I do think it's good practice to like move the decimal with your pen or pencil. That way you're counting decimal places and not zeros, which is a trap that some people try to do when they make a shortcut. All right, now I'm going to take these two numbers in the bottom and I'm going to write them in standard notation, which is taking them out of scientific notation. Now, the first thing I do here is I see that the first thing I notice is that I have an exponent that's negative. So in my head, if I see an exponent that's negative, it means that I have a number that is smaller than 1. So that also tells me that the 847 would be at the end of a number and not the beginning. So I'm going to start by writing 874. And then I'm going to put that decimal there just for a second. And then I'm going to start moving the decimal to reflect the -4 places that the decimal was moved before. So I'm going to move it 1, 2, 3, 4 spots. And by moving it 4 spots, I'm going to go ahead and add 0, 0, 0. And then here's going to be my decimal. And I usually put a 0 in front. You don't have to, but that just makes me feel a little bit better about the number itself. So in this case, 8.74 times 10 to the -4 is also 0.000874. Looking at question B, 2B, I see that we have 9.26 times 10 to the third. I see that it is a positive exponent. So that tells me the 926 is going to be at the front of the number because my number is bigger than 1. So I'm going to take the 926 and I'm going to put a little bit of a decimal there. And I'm going to say, okay, the 3 tells me I have to move the decimal 3 places as long as I'm making the number bigger than 1. So I'm going to move it this time to the right. 1, 2, 3 spots. And I have to add a 0 here to assign the right value. I would also probably put a decimal there, and then we can practice going forward. Let's see. Is there anything else I need to tell you about scientific notation? Well, first of all, I apologize for my picture in the corner. That's a terrible choice of picture placement. And I don't think I'll ever do that again, but I'm too invested in the video at this point to redo it. I know what to tell you. What I usually tell students when they say, like, when do we have to write in scientific notation or not write in scientific notation? I usually say if the number is bigger, oops, I should erase that and get that right. So I usually say if the original number is larger than 10,000, put it in scientific notation. And then the other thing I usually tell students about the smaller numbers is I usually say if the number is smaller, well, maybe not smaller. Let me erase is. If the number has more, I don't know what's going on there, it has more than 4 leading zeros, that is zeros at the beginning of a number, write it in scientific notation. The only thing about that would change would be the fact that if you're doing a worksheet or you're taking a quiz or a test, and we tell you to put it in scientific notation and it doesn't fall into one of those two categories, and you say, well, that's what the video said, we're going to mark it wrong. So just be aware that if we ask you to do it, as part of a test or a quiz, put it in scientific notation. But if you're like out there living your best chemistry life, and you see a number that's bigger than 10,000, you have every right to put it into scientific notation. Hope you found this video to be helpful, and you are supposed to do the scientific notation worksheet in your packet by the next time that I see you. And so for most of us seeing this video, that will be Thursday. Have a good weekend.